Okay, let's begin. So, here we go. Velocity time graphs. Now, the number one thing, the number one error, the number one problem that people make is they don't know what kind of graph they're dealing with. On the test, you will see position time graphs and you will see velocity time graphs. You have to treat them differently. So it's very, 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 maybe one more, very important that you check what kind of graph you're talking about or looking at, right? Okay, so we're first going to look at average acceleration. Average acceleration is calculated the same way that average velocity is calculated on a position time graph. That is by using the slope formula, right? And what is that slope formula? Rise over run, or y2 minus y1 all over x2 minus x1. Now, I'm always surprised at the number of kids that maybe flipped it the wrong way. They got the x's on top. They go x1 minus y2 or something like that. Don't make those mistakes. Get that on your cheat sheet and get it done right and practice. Okay, so I'm going to show you an example, and then you're going to do a bunch. And then we'll check those answers, and then I'll give you some practice time to work on. Okay? So make sure you're paying attention when I do the teaching part right now. Because I know what happens is people wait until they actually have to do it, and they go, I don't know how to do that, right? But you realize I'm showing that to you right now. Okay, so we're going to find the average acceleration for each interval. So we're going to do the first one together. We're going to do the first one together. So we're going to find the slope of interval A. Now you have on your sheet, I think you have the letters A, B, C, D, E, and F, right? You have that on your graph? Okay, so this is A, and then this one is B right here, and then C goes down to there, and then D goes to there, and then this is E, and then this is F, okay? So we're going to find the slope, we're going to find the average acceleration for interval A, and that means finding the slope. So let's do that. So what is our y2? What is our value for y2? This is x2, y2. Our value for y2 is 4. So it's going to be 4 minus, what's our y1? 0. Right? The y4 minus 0. And here are the x's. 2 minus, what's the x here? 0. And 4 minus 0 is 4. 2 minus 0 is 2, and 4 divided by 2 is 2 meters per second squared. That is the slope of that portion of the line. And because it's a velocity time graph, the slope tells us the average acceleration. Acceleration is the slope of the VT graph. Okay, so I'm going to start the clicker portion. I've given you the answer to part A. There's no excuse for getting part A wrong. No, you can still join, yeah. Okay, now please note, listen carefully because we had several people this morning that didn't understand. Okay, so for question 1, 2, 3, 4, 5, and 6, you have to answer a number. Up to 6 are numbers. See it on the sheet? And then what does question 7 say on your sheet? What does question 7 say on your sheet?
Stop.
Doesn't it say something like, when is this object stopped?
Yeah.
Okay, and I've given you the intervals, and those intervals again are A and B and C and D and E and F. There is also one more answer, that is interval G, which stands for never. Okay, and you have to answer, and more than one answer is possible. I repeat, more than one answer is possible for questions 7 and 8 and 9 and 10 and 11. This will take you a few minutes.
So wait, you have to answer both or just one?
Yes, you have to get them both right to get the mark. Okay, so you can go up to number 11 now. Go. Well, I'm pleased to see that everyone got question 1 correct. Good start. Well done, everyone. Thank you for not messing that up. Question number 2, though. The correct answer is 0. Why is it 0, Kaylee? Because it's not moving. It's flat. Oh, hang on. Hang on. Let's not go with it's not moving. Because what are we asked to find? No, we are asked to find the acceleration. If the acceleration is 0, does that mean it's not moving? No. It's not. It means it's not speeding up or slowing down. So the slope here is 0. The slope here, now, we seem to have lots of different answers. So let's have a look at this. Okay, and I would suggest you write this down. I would suggest you write this down, especially if you got it wrong, right? So from 5 to 7, the second point is this one here. The y value is 0, so this is going to be 0 minus 4, right? 0 minus 4, and the x's are from 7 to 5, which is minus 4 over 2, or minus 2 meters per second squared. You're finding the slope. The slope of the velocity time graph is the acceleration. Minus 2. Question number 4. It's the same number. How do I know it's the same number? Look, it's the same line. If you want to do it, what's the y value right here? Minus 3. The y value here is 0. So minus 3 minus 0. The x value here is 8.5. The x value here is 7. So that's minus 3 minus 0, which is minus 3. 8.5 minus 7 is 1.5. 3 over 1.5, minus 2 meters per second squared. Okay? Question number 5. What's the average acceleration? 0. The line is flat, not straight, flat. 0. Question number 6. What's the slope? It is indeed 1. Let's do it again here. The y value here is 0. The y value here is minus 3. So that's 0 minus minus 3. The x value here is 14. The x value here is 11. 0 minus minus 3 is 3. 14 minus 11 is 3. Hey, the answer is 1 meter per second squared. That is the slope, 1. Okay, now, when is this object stopped? The correct answer is G, never. Why is it not stopped B and E? Constant speed. Again, remember, not a position time graph. If it was a position time graph, a flat slope means it stopped. Are you going to make that mistake on the test?
Yes.
Don't. Well, I'm telling you right now not to. Check what kind of graph it is and think it through. Okay, this means that the velocity is in fact 4 meters per second. That is not stopped. The only time that it is momentarily stopped is, well, right there, and right there, and right there, right? Paused. Instantaneously 0. But the question didn't allow you it only allowed you to enter intervals, right? So there are no intervals where it is stopped. What about moving backwards? Moving backwards means negative velocity. Where is it negative? D, E, and F. D, E, and F. Not the slope. The value has to be, right? This is moving backwards. That's negative velocity. We're not talking about slope. Moving backwards refers to the velocity. Negative velocity, D, E, and F. Give me the nod of understanding. Number 9, when is it slowing down? Here's the hardest question of the day, I think. You slow down when you approach 0. When the velocity approaches 0. Where is it approaching 0? Right there and right there. And you will notice that it's approaching 0 from a negative slope and from a positive slope. Kayla, you watching? What did I just say? Uh-huh. And we are approaching 0, Braden, here. Approaching 0. So that's intervals what? C and F. C and F. Approaching 0. I believe the next one is, when is it speeding up? Speeding up when you're moving away from 0. Moving away from 0. Where do we move away from 0? There and there. Away from 0. A and D. And the last one, when is the object moving at a constant speed? And the answer is B and E. And it looks like we had all sorts of different answers there. Again, you must keep in mind what kind of graph we're talking about. Here we are talking about a velocity time graph. Okay, now, I'm going to do displacement tomorrow, so I'm going to skip over that. I want you to go to the next one there where I think it's on the 3rd page where it says instantaneous velocity. Can you find that? It's on like page 3, I think. Got it? Like the 3rd side. Page 2, the front side of page 2. Front side of page 2. I think it says page 3 at the bottom. The front side of the 2nd page. The front side of the 2nd page that's numbered page 3. Okay. Instantaneous velocity. How do we find instantaneous velocity? What kind of graph is this? A velocity time graph. It is a graph of the velocity, so you simply do what? Read it off the graph. Something we've done right from the start. Read it off the graph. So for example, the v-inst, when t is equal to 6, the 6th second, is right there. What do? Read it off the graph. When t is equal to 6, the velocity is equal to 2. What is the v-inst at 13 seconds? -1, right. Got it? V-inst. What if you're asked to find instantaneous acceleration? The instantaneous acceleration is determined the same way off VT graphs v-inst was determined off position time graphs. That is, find the slope of the VT graph. Find the slope of the VT graph. You may need to draw a tangent line. When do we do that? When the graph is curved. For example, A-inst at 6 seconds, which is right there. How do we find acceleration? We're going to find the slope because it's a straight line. We're going to actually find the slope, so I'm going to pick those 2 points. And that's going to be 0 minus 4, right? 0 minus 4 all over 7 minus 5, which is minus 4 over 2, or minus 2. What's the v-inst at 12 seconds? Right there. V-inst at 12 seconds. Right there. We're going to find this, or not v-inst, acceleration, instantaneous acceleration. We need to find the slope right there. 0 minus 3 all over 14 minus 11. 3 over 3, which is 1 meter per second squared. Okay, I think you guys have been taught everything that I need to show you. Now, again, I'm going to go through that summary thing tomorrow. Find graph number 1. There are 4 graphs, right? 4 practice ones. Okay, find the first practice graph. You can do, in graph number 1, you can do A to F so far. In graph number 2, you can do A to E. In graph number 3, you can do questions 1 and 4. Okay, and we'll do the rest tomorrow. I'm going to leave graph number 4 out because they're kind of all over the place. I will point out that on the back page you have the answers, you have a link to the solutions, and you have a QR code to the solutions. So you have a few ways to find out how to do it. And you have about a half an hour, so you got lots of time to practice. We will do displacement tomorrow.